everybody, Johnny Bannon here at Trepa Technologies, and in today's video we're going to do our port security lab. So if you're following our videos in order, we just did our port security lecture. We went over what port security provides us, what it actually does for our layer 2 and our campus network or infrastructure, and now we're going to get into the actual configuration. This video is going to be part of our CCNA full and free course. If you like this kind of material, guys, please feel free to share or check out that link in the description below to check out our full-paced CCNA course or our live virtual training. Now with that sales pitch out of the way, let's go ahead and get started. So I'm going to minimize my face here, and then we're going to jump right in to our port security lab. So just a couple things to note with this port security lab, guys. So EVNG, if you have one of your devices online, so we have our switch here that's going to be the main component of our port security lab, right? We're going to configure port security on this switch. The whole point of port security is that you can't have, or you can limit the amount of MAC addresses assigned to a port. So the default behavior of port security is only one MAC address per port. That's the default, right? So that's the default is one MAC per port. So let's just say we configure port security on this switch, and now only one MAC address is allowed on this gig00 interface. If I delete this connection and try to re-add the connection on this PC to try to simulate a second MAC address, you cannot make that connection in EVNG with the device still turned on. Obviously, this does not mimic the real world. You can plug in and unplug cable, Cat5 cables to your switch at any time. It's completely hot swappable, right? But in this network emulation environment using EVNG, for some reason, and we can just show you, it doesn't let us connect if one device is turned on and one is off, or if both are turned on. You can see here it just won't do anything, okay? So what I'm going to have to do here to simulate you guys port security is we're going to use the sticky command right away. We're going to use a sticky command. So what that's going to do with this turned on PC here is that is going to assign or really configure to the NVRAM and startup config this computer's MAC address. And then I'm going to turn this switch off. I'm going to turn this computer off. And then we're going to connect this PC to that switch, turn them both back on. And with that sticky MAC address now, we're still going to have that one MAC address assigned to that port. So port security is still going to believe that even though this isn't connected, that because that sticky command is written to the running config, it's going to believe that on gig00 it's still this computer's MAC address. So then when we can plug this computer in, then it's going to trip port security. So that's how we kind of simulate port security in EVNG. We just utilize the sticky command, which is fine because that's that additional an optional configuration that we might use anyways. So that's what we're going to do here, okay? So it's going to be a little bit of a step-by-step process. We're going to turn off the switch, turn it back on, and then we'll be able to see port security be tripped, and then we'll go and clear port security, and then that'll be the end of the lab. So with that being said and that out of the way, let's go ahead and get started. So what we're going to do now is console into our switch into our PC. So I'm already consoled into the switch here. Okay, and I'm also consoled into this PC. So now this switch is completely empty. So what I'm going to do here is a couple things. I'm going to create the VLAN. I'm going to name it just test, or it doesn't really matter the name. And then I'm going to go into gig00 and just do our basic switch port configuration, assign this to VLAN 10. And then I'm going to type in interface VLAN 10 IP address 192.168.10. Actually, that's going to be messed up. Let's try that again. Interface. Let's go ahead and do our logging synchronous here on line con 0 so it doesn't keep cutting us off there. Okay, and then we're going to create an SVI. Now you may be wondering, why are we doing this? Well, because, again, since we're in EVNG emulating equipment, emulating Cisco switches, emulating a virtual PC, just by it being plugged in, it doesn't actually do any communication with that switch. Now, on a normal network, when we plug our computer in, immediately it starts just broadcasting stuff, right? Especially with STP, if we still have it turned on. It automatically does DHCP when we plug in a computer to our network. So the MAC address is going to be in the source, in the MAC address table of that switch. But as we see here in EventG, it's plugged in, but there's been no communication made. So we type in do show MAC address table. Nothing. It's empty. And that's because we haven't sent any communication from PC2 to the switch yet. So what I'm doing here is I'm going to create a DHCP pool and then a switch virtual interface, and then I'm going to have PC2 send a DHCP request, and then we're going to be able to get that source MAC address. Okay, so just a quick, simple way we can emulate port security in our network. All right, so now let's configure our default gateway. All right, now we're going to do the DHCP process, so IP DHCP here. Then hopefully we get an IP address so we know we configured DHCP correctly still. And now because of that, let's go over a few things. So we're going to have the MAC address table now populated. And now let's go in and actually configure port security. So I'm just going to expand this a little bit more for you guys. All right. Now back in our switch port, our interface, the first command we configure is switch port security. That's actually going to enable it on the switch. If we were to just immediately start doing our switch port security MAC address sticky commands without this, it wouldn't enable port security. So remember, this is the very first step. And now this is going to be the first two commands we do. And now let's check our port security table. So command is just do show port security. And as you can see here, we only have one maximum address. And it says the current address count is 0. Now why is that? And that's because we didn't have this enabled when that PC initially did its DORA command. So let's just send more traffic. Let's just ping our default gateway here. And then let's redo that command. And as you see here now, we're counting that MAC address. So it says we have a maximum of one address that can be on this port. And we currently have one. So if this was a real world environment and I unplugged PC2 here and plugged in PC3 to gig 00, that would trip port security. But because we can't do that in EventG, we can't hot swap Ethernet cables, what I want to show you here is the running configuration of gig 00. And because of that sticky command, look at this. It's actually captured the MAC address and written that to the running config. So if we come in here and look at this PC's MAC address, that matches, that is PC2's MAC address. And now if we type in do write, even when we restart this switch, and when we do that, it clears the MAC address table, because the MAC address table runs in CPU and in memory. When it reboots, it's still going to have this security violation because of this sticky command. It's going to say, no, we have one MAC address on this interface. Even when we reboot, this is all part of our running config now. So we'll still have that one security violation, okay? Now, before we move on to turning off the switch, turning off the PC, and plugging in PC3 to actually trip port security, let's do a few more commands here. I want to show you just how we can statically set the MAC address. We can just say, hey, no matter what you do, we want this MAC address. We also have the maximum. So by default, the maximum is 1, but we can put on there the maximum could be 5, 10, or 2. And then the default violation is shut down, but we can change that to the other two we have, protect and restrict. And these can be used for additional configuration, like we'll generate a syslog message, then we can send that syslog message to a syslog server, or maybe an SNMP server, and then maybe we can tie in infrastructure as code, like Ansible, into the reading of those syslog messages to go ahead and clear it automatically. So much we could do, right? In case you're wondering what are these for, if it doesn't shut down the port and do that protection, okay? So a lot of different things we can use with that. All right, so we have those additional configurations that you just saw, but for this lab, now we're gonna go ahead and finish it up. So I'm gonna just save that config again. And remember, the point of this is that we did our sticky command. So we look at the running configuration of gig 00, we see that PC2's MAC address is assigned to that port now. It's saying, nope, that's the MAC address on it. And then if we run do show port security, we see that one violation count. Now, let's go ahead and stop this. Stop this. I'm going to delete that connection here. And then we're going to connect PC3 to gig 00. And then we're going to start up this switch and start up this PC. And if we come back to Secure CRT, guys, this switch is going to take about 2 to 5 minutes to fully boot up. So I'm going to go ahead and pause the video here. And when we come back, we're going to have PC3 send a DHCP request. And that's going to trip port security. And we're going to look at the syslog messages. Before that, I'm also going to start a packet capture on here. And that's going to let us see if we see anything on the packet capture on the wire. I don't believe so. I believe this is just going to be internal to the switch. But let's go ahead and see when we come back. Okay, everyone. Now that we're back, before we have PC3 send a door request, DHCP request, and we get its MAC address, source MAC address learn, and then trip port security, let's just make sure that we still have that sticky MAC address command working. So let's look at the running config. Yep, that is PC2's MAC address. And just to verify, we can type in show IP here and see that this is PC3's MAC address 03. So it is different. Then if we type in show port security, you can see we still have that one current address. So we're about to get a security violation once we send some traffic from PC3 to the switch on gig 00. Okay, now that we've done that, you're going to notice that our door command is not going to work. Why is that? Because if we go back here on the switch, we'll see that we have a port security violation. So let's go ahead and now do additional show commands. So if we type in show port security, and you can even look at this, guys, our packet capture completely stopped. And why is that? Because the port's now error disabled, so it's no longer functioning. So there is no more packets coming across there that we can actually capture. Pretty cool. So we can see our security violation and look at the action, shut down. So if I type in show interface status, you can see here that gig 00 is in an error disabled state. If we type in show interfaces, gig 00, we're also going to see that here that's error disabled right now. And let's just go ahead and get out of there. And there used to be a command that I used when I was on using Catalyst switches called clear port security. But we're not going to get into that. Sometimes you can clear the violation count here. But ultimately, to get a port out of error disabled mode, you're going to have to shut it and no shut it. So let's go ahead and do that. So the first thing we're going to do is get into gig 00. So what we're doing here is now clearing that port security violation, clearing actually the error disabled mode, okay? So now that it's shut, and then we're going to go ahead and type in no shut here. And then if we come back in here to do show port security, now we don't have that security violation anymore, but we still have one current address. So let's go ahead and look at the MAC address table here. So it still says that it's 02. Now, why is that? Well, because check this out, guys. So we do type in show run interface gig 00. Look at that. It's still sticky right here. So what do we do in this scenario? So like I told you, there is supposed to be a command that it probably is not running just because this is an emulated switch. But it's called clear port security. And what that'll do is clear that sticky and it'll clear this current address count. But for some reason, it's not showing up on this switch. So even if PC3, we sent information again, check this out. It's going to trip port security again. So how would we do this? Since I can't show you it, I just want to bring up the Cisco documentation on how to do it just because we can't emulate it here, okay? So I want to show you that there is a solution to this. Okay, so as you can see here, I'm going to zoom in. So we can run this command called clear port security dynamic, and that'll clear the sticky on the sticky MAC address that's learned on our actual switch. Another solution that we can do is actually just go into that switch. Let's go into interface gig 00, shut it. We can type in no switch port security, and then we can no shut it again. Add on switch port security, and then let's see if this will work. So as you can see here, if we type in do show port security, now we no longer have that security violation, because now we should have learned, if we look at our MAC address table, we should have learned PC3. So now if we type in do show run interface gig 00, still has that. So actually what we're going to do here is just note out that sticky command, and then we'll run that DHCP request again. So we'll shut this. We're going to look at our config again, and let's see. So we shouldn't have the sticky. We'll type in no switch port security. We'll no shut this, and then re-enable port security, and redo the command sticky, and then send that DHCP request again. And now we type in do show MAC address table. Let's look at our running config since we're not seeing it there. Interface gig 00. Now we have the sticky command, okay. We'll look at our port security. Okay, so now there's no addresses on there. Let's run this one more time. And now we're good to go. So I'm going to recap everything that just happened, guys. So essentially what happened here is, since we have the sticky command enabled, even if we flap the port after a port security violation, even if we get rid of this command switch port security, this sticky command is still going to be there, only allowing that MAC address. So what we actually have to do to fix this issue is just know out everything, know out all of this. Now this is going to be iOS independent. As you can see here, you can dynamically clear the port security violations, okay? And then even with that sticky on there, depending on the iOS version, you should still be good to go. Now, I think what we can learn here is that sticky is a good feature to have with port security, but obviously it can cause some issues if we're trying to quickly just move around our office if our MAC secure addresses are still 1. Now, in a real-world environment, more than likely, this number, you're going to want to be 2. And that's because when we connect our switches to our phones and then off to the computer here, this is going to be 2 MAC addresses. So typically, on a if you have a Cisco unified calling system, right, or unified call manager, whatever, using Cisco VoIP phones, that's going to be your configuration, and that would be at 2 MAC addresses, okay? So that's going to be it for this lab. Again, there was hopefully not too much confusion on this. Port security really is a simple thing. It just lets you deny the number of MAC addresses on a port. And with sticky, that'll actually write the first MAC address learned to the actual port itself, even on a reload. And it'll still be part of that violation count, as we've seen. Even if we flap the ports and get rid of this command and this command, it doesn't matter. You got to get rid of the entire command that's written into that running configuration, or excuse me, written into that startup configuration. All right, guys. So that's going to be it for our port security lab. I hope you enjoyed it. If you're an active duty soldier, reserve, or National Guard, and you want to come to our CCNA live virtual training boot camps, or get access to our self-paced course of over 1,200 practice questions, labs, and access to our team, click that link in the description below and see how you can use your $4,000 a year in credentialing assistance to come to our course. Or if your unit uses unit funds to do in-person boot camps, please recommend us. We'd love to come out and train your unit. We have great pass rates. We're bringing all of our equipment, have all of our labs. It's a great class, and we have high pass rates. I want to thank you for viewing, and do not forget to like and subscribe.